Hi everyone. Today I'm going to start chapter 2, which is about describing data. We have six sections in this chapter 2. So let's start with section 2.1, which is about categorical variables. So in this section, we need to talk about two things, two types of two categorical variables, which is one categorical variable and two categorical variables. Those are two different ways that we need to treat these categorical variables. So first part of this section 2.1 based on one categorical variables, and then we will move to talk about two categorical variables because we have to treat these one or two categorical variables in different ways. We will dig deeper how to summarize these statistics under one or two categorical variables, and then how to visualize these categorical variables. All right. So I hope you guys remember this bigger picture about the statistical inference, which is if you have a population right here, and then we okay, this is the population. So we take a sample from a population, do our analysis, and then make a conclusion, make a general conclusion about this population, which this process, this whole thing we call statistical inference. And also, I mentioned at that time, if we just consider one particular thing, either population or sample, do our analysis, and then uh, interpret about itself, we call descriptive analysis. So, descriptive statistic. So that can be either population or sample. When we think about descriptive statistics, uh, we need to summarize, or we need to visualize things. Summarizing and visualizing these sample data or population data, we call descriptive statistics. Uh, these methods, the summarizing statistics or visualization, these things depends on the type of the variables, because we have two different variables, categorical variables and quantitative variables. So if we have categorical variables, then the summarization, the summary, the way how we need to summarize this and visualization, it change. If we have quantitative data, then things gonna be a different story. So we have to learn these two different types of variables in different sections. All right, so one categorical variables. So one categorical variable section. Now we'll first start with a simple example. So it's about, this example is about adults smartphone usage, actually cell phone usage, into 2012, which is about a decade ago. So at the time we had Android, iPhone, BlackBerry, non-smartphone, smartphone, and no cell phone, something like that. So this study, they take a random sample of US adults in 2012 and check whether they have these kind of phones or not, or check what kind of mobile phone they have. So based on that analysis, they have summarized their results. So this is a particular way to summarize the result. Here you can see the category name, what kind of category is this, and then in this column corresponding total or corresponding count, we call frequency. So these are the values for the categorical variable. See, Android, iPhone, BlackBerry, non-smartphone, no cell phone, and these are the corresponding count. So we call this frequency. Since we have categories and frequencies, this summary table we call frequency table. It shows frequencies of these categorical variable, right? And down below here, you can see total, which is the summation of all these frequencies. This is the sum. Okay, right. Let's try to work with this example. This is about randomly selected 15 sample of students. Okay, and their food interest. Okay, so their responses are as follows. So they like pizza, burgers, chicken wings, burritos, pizza. So likewise, there are 15. There are 15 um, responses. So now we are going to summarize these 15 responses using a frequency table. All right. So let me draw the frequency table. So this is going to be my table. So I have column names. Oh, sorry. Uh, all right. Uh, okay. So these are columns. First one is food or food name. The other one is frequency. Okay. So the food's gonna be there are four unique values: pizza, burger, chicken wings, and burrito. You can see all other things, all other um 11 interests are repetitions of these four. So here is a pizza, there's a burger, and chicken wings, finally burritos. Let's count. How do you get the frequency? Just count. So pizza, how many? One, two, three, four. There are four. Burgers. Sorry, burgers. One, two, three, four, five. Chicken wings. One, two, three. Just three. And burritos. One, two, three. All right. Now, one last thing. You have to check the total of these frequency. So total is here based on my numbers 9, 12, 15. Okay. It is 15. So this total should equal to the total or the sample size we had. So we have 15 responses. So this equals 15. So you make sure you just once you finish this frequency, once you constructed this frequency table, check the total with the um, values you have, with the count you have. Okay, most of the time, if this the total of these frequencies will not match with the uh, count that you have. So if you get that kind of situation, that means definitely there is a problem. Okay, right. So this is the frequency table. So we have summarized all this story in within this table. So next thing is to calculate the proportion. I think you already know how to calculate this proportion. So simply you can divide that count based on that particular category by its total. So the number in category or the frequency divided by Total sample size. Total sample size is this one down below. Total. Okay. All right. If you are dealing with sample, this proportion we call p hat. P hat. So in the statistics, in this course, we are using some standard notations. So you have to use um, those notations. Okay, so at that point, if you use p hat, you don't have to mention proportion for the sample. Okay, if you mention p hat, I know that's based on a sample, so that called p hat. The same thing goes for the population proportion, population part. We denote it by using simple p, no hats, just simple p. Okay, so both of these notations refer the proportion, which is the frequency divided by the total sample size. Okay, there is another example here. Uh, People were given different water taste and asked to choose their choices, to choose their top choices. So this is a blindfolded kind of uh, study. So they don't know what kind of water they use. So based on that, we have frequency table here. As you can see, tap water, aquafine, Fiji, Sav's choice. So there are four different types of waters, and the based on the choices, you can see the count. Okay, so this is the frequency table. It doesn't matter, it's either horizontal or vertical, that's fine. Now we are going to, what we have to do is simply we have to find the relative frequencies. Simply we need to find the proportions, right? Before we do that, let's move on another proportion example using the same data we use to construct the um, frequency table. So in here you can see this is the frequency table, and I'm going to add another column to find out relative frequencies, or uh, find out proportions. So let me name this column relative frequency. Relative frequency, right. Then I'll modify this table a little bit. Okay, now I'm going to calculate the proportions. So how do we calculate the proportion? Each frequency divided by its total. So total, you can see 2253. So each frequency, for example, this one, 458 divided by 2253. So you can use your calculators and get the answer here. And the next one, this frequency, which is 437 divided by 2253. So total, it doesn't change throughout this problem. Okay, but each frequency it changes, right? So for the BlackBerry it is 141. So 141 divided by total 2253. This one 924 divided by 2253. Last one 293 divided by 2253. So you can use your calculators to get answers for these fractions. Okay, so this proportion column we call relative frequency, because these values relative to its total. So you can see the numbers uh, later. Uh, I can show you these numbers in this relative frequency table. So these are those relative frequency values. Right. There is one more thing. In relative frequency table, you have to check the summation of these values, these relative frequency values. Summation, you have to consider the summation. So if you get the sum of these values, this must equal to 1. See all the numbers in the relative frequency column, sum is 1. If it is not 1, it's going to be a problem. Sometimes if we have like most of sometimes we have numbers doesn't give us 1, but at least it should closer, very closer to 1, at least 0.99 something. Okay, all right. So next one is to visualize these one categorical variable. There are a few graphs, or we call charts, we use in this one categorical variable. First one is the bar chart, or we call bar plot or bar graph, whatever, it doesn't matter. This bar chart or bar plot, uh, using this bar plot, we can show these frequencies or relative frequencies. For example, here, using the same example, you can see uh, each value in the categorical variable, which means Android, BlackBerry, Nocell, non-smart, iPhone, they have a separate bar. Okay, so each bar represents its frequency by using the height of these bar. Okay, sorry, height. So height represents the frequency. Height represents the frequency. Okay. For example, mm, for the Android phones, we had about 458. Here we can approximate about 450. It's really hard based on the scale, but when you are drawing these kind of bar plots, you can decide the scale. So it's not a big deal. But in bar chart, there is a one more thing you need to know. When we are drawing a bar chart, there is a gap between each bar. See, there is a gap here. There's a gap here. So each bar is divided by a small gap. This gap between each bar is equal size, and that's a unique for bar charts. Okay. And below in this x-axis, this horizontal axis, we measure the values of that categorical variable. Okay, right. Next chart is pie chart. So we most of the time it is easy to use a pie chart rather than a bar chart, because this pie chart is kind of a circular shape, and relative frequencies we denote by using a slice. It's like a slice of the pie. The size of this slice represents the relative frequency or the frequency. In the pie chart, we use relative frequencies. Unlike a bar chart, in the bar charts we can use frequencies or relative frequencies, but in the pie chart we have to use relative frequencies. We can use relative frequencies as a decimal or as a percentage. In this case, you can see Android. I mentioned the relative frequency. It was about, yeah, 0.23. So this much is 0.23. This area, it is 0.23. Sorry about this. 0.23. All right, now I want you to go to stat key, because stat key is the software that we are using in throughout this course. And you don't have to draw these graphs. So whatever the graph, you don't need to draw by using your hands. We can use the software to do that. So let's use this stat key. I think I showed you how stat key how stat key works in I think the first day maybe. So let's go to the stat key and see how these work. Right. You can go to your browser and type stat key. It will pop up, and this is the interface of the stat key. First, actually, in this first page, the home page, we have three columns. First one you can see here, descriptive statistics and graphs. Second one is about bootstraps, confidence interval, then randomization hypothesis test. So for the chapter 2, we need this first column. So don't worry about the column number 3 and column number 4. Okay, right. So now we are working on one categorical variable. You can see it here. Clearly it has mentioned one categorical variable. So click on it. Right, one categorical variable. You can select the dataset you need. Do we have example dataset? Yeah, cell phone types. So here we have our example that we were talking about, cell phone types. Once you find out your data set from this drop down menu, for example cell phone type, click on it and you can see this bar chart. Okay, it automatically draws this bar chart, and also the right hand side you can see the summary statistic. This is a relative frequency table, and when you move along this you can see the corresponding bar. For example, Android, you can see this brown color belongs to Android right here. It's count and proportion, and down below you can see summation of this proportion is 1. Okay, right. So if you have a question, actually in chapter 2 you have to draw graphs and you have to attach them into your final homework answer. So whenever you need to draw a graph, you have to use that key. Please crop this page and attach it to your answer. Okay, uh, in order to go through that how to attach these stat key answers and those kind of things, I have already uploaded a document. It's a fully explain everything I have explained in that document, how to crop this screenshot, how to crop this screen, or how to take a screenshot and attach it to your answers. So it's clearly mentioned how to do these things. Log into the Moodle page, your Moodle account, and check that document. If you have any questions regarding to how to attach things or how to use this, then come and talk to me. Okay, so now as I mentioned, simply you can take this screenshot and attach it to your answer. But in statistics, whenever we have drawn something, we have a graph, then we have to explain what is going on in that graph. It can be a graph or it can be a table, it doesn't matter, but we have to explain at least by using one or two sentences. You have to mention what is this. That is a part of our job. Okay, so although you get this nice looking graph, you have to write something about this graph or about this table. It depends on the question, but for example you can write in this table A standard cell phone count is higher than all the other options that we had in the past, or you can say the frequencies for Android and iPhone about similar. You can see in the exact numbers here, but if you check this graph, you can uh, explain things like that. Or you can say BlackBerry has the lowest uh, count among these five values, among these five mobile phone types, something like that. So at least try to write a one or two sentences to explain the graph. Okay, right. Let's go back. So this was the example I was talking about. Uh, since I have explained everything, I don't think I need to go through this again, especially this one. Interpret your results by looking at the bar chart. So you have to write something. Remember, you have to write something. Okay. Right. So that's all about one categorical variable. Let's see what we have, what we talked about. We talked about summary statistics, especially proportions, frequency table, relative frequency table, and then we talked about visualization stuff, which means bar chart and pie charts. So those are the main ways that we can visualize one categorical variable. So based on one categorical variables, if you have any questions, please talk to me. Do not wait until the last minute. Just come and talk to me. All right. So my plan is to cover the second part of this section as well. So the second part of this section 2.1 is about two categorical variables. Two categorical variables is a bit uh, harder to analyze than one categorical variables, but it is uh, super nice to talk about, because in these two categorical variables, we try to see the relationship between these two categorical variables. So we have an example here, actually data collected from our university students about their relationship status. So relationship status is a categorical variable. It can be a few different unique values. I'll show you those values just in a second. And the other categorical variable is a gender. For now, we keep this gender as a binary. So we have male and female. So those the results from those study, you can see here it's summarized in this table. Okay, so in this table you can see column wise you have gender female, male, and row wise you can see relationship type. In a relationship, it's complicated, single. Okay, so we have two categorical variables in this column. One categorical variable use columns, the other categorical variable uses uh, rows. So this kind of two categorical variable tables we call two-way tables, because there are two ways to show these two categorical variables. Okay, all right. So how do we read these tables? That's super important. As you can see here in this first, the second column, female. In this variable holds all female counts regarding these relationship types. For example, this first 32, the first number here is females who are in a relationship. The second value 12, which is females who think it is complicated. Right here, 42, sorry, 45. This 45 is, let me draw this one. Okay, this 45. Okay, Oh, sorry, let's use a pen. Okay, this 45 right here, that means male who still single. Okay, and this in this blue color area you can see 107 under female. That means this 170 is the summation of these values in this column. Okay, so all females in this sample is 107, all males in this sample is 162, and the row wise, this pink color, you can see 42, which is the all students who were in relationship, and this 19 who thinks it is complicated, regardless of male or female. Okay, so this 169 at the very end, this is the grand sum or grand total. That is the total. Regardless of these categorical variables, this represents all the data that we have. That is 169. There are 169 students. Right. So try to clearly understand how to read these two-way tables. Okay, because we have to do some calculations based on these two-way tables, and probably you will get a question for the exam from this two-way table because it's really important. Okay, right. Let's see how this works. Uh, Actually, it doesn't matter which side we use, either row or column. It doesn't matter. Okay, you can swap these columns and rows as you want. Okay, all right. Uh, First question: what proportion of students in this sample are in a relationship? So, what proportion of students in this sample are in a relationship? You can see the answer here, but try to think how to get this, how to get the answer. What proportion of students? So you have to find a proportion. You know how to find a proportion, which is frequency divided by total. Okay. In this sample, students in this sample are in a relationship. So first you need to find out students who are in a relationship. So where is students? This one. Who are in a relationship? There are 42 students. They are in a relationship, right? Then what is the sum? What is the total? Total students is 169. So 42 divided by 169 equals about uh, roughly 25%. That's the answer. So this answer based on what proportion of students in this sample are in a relationship. Okay, let's see another one. Uh, what proportion of females in this sample are in a relationship? What proportion of females in this sample are in a relationship? Right. How about females? So where we can see the female count, it is here, right? It is here in this column. So female count, regardless of the relationship status, it is in this column, right? So at the end of this column, we can see the count. So females in this sample is how much? It is 107. So total for the females in this sample is 107. Right. Are in a relationship. So how many females are in a relationship in this sample? So this is the female column. How many? 32. 32 of them in a relationship. So 32 is the frequency, and the total corresponding to the female count is 107. So 32 divided by 107 is about 30%. It's about 30%. Okay. Uh, let's go forward. All right. Let's think about another. Example: what proportion of people in a relationship in this sample are female? All right. What proportion of people in a relationship? For now, you have to first you have to think about proportion, the total of people in a relationship, people who are in a relationship. So in a relationship, that means relationship status in these rows. So this is a row wise problem. uh, People in a relationship, this row, and this is the total of people in a relationship. Now you have to check the other part of this question, are female. So in a relationship this much, and in a relationship how many females? It is 32. So female frequency is 32. In a relationship frequency is 42. So 32 divided by 42, which is roughly 76%. Right. So that's the easiest way to find solution for these two-way tables. So next day, I think it's better to talk about how to use these techniques to find uh, answers for these questions. Next day, I'll talk about more examples regarding these two-way tables. And I think this is enough for today. So please go through this again and try to understand what we were doing here. So if you have any questions about this section 2.1, still we haven't finished it. We have to uh, do some few things. However, if you have any problems, if you don't understand things, at least watch this video twice, and still you don't know how to get this, just shoot me an email or come and meet me in next week. Okay, I think it's clear for you guys, so hope to see you next day. Have a great day.